Hello, hi, good evening, good morning, good afternoon from wherever you are. This is SBOA class of 2003 Learning and Unlearning series, an educational series that we have been trying to instantiate through our lives starting 2024. The first session, the first season was in 2024. The kickstarting season 2 of this series in September 2025 in a very basic topic, but a topic where Elon Musk of the world are making rapid progress. So everybody needs to know what is this is into rocket science and the space exploration. We have our beloved friend Akshay, who is fortunate enough to spare his time, who's working with ISRO Sriharikota. Over to you, Akshay, for this session. This is recorded on September 27th, Sunday, 2025.
Hello everyone. I just start and I give you a basic overview of how a rocket works and what are the things which makes the rocket fly. So it will be very basic. I'm not going to go into any technical complicated details. I'll try to make it as simple as possible so that even a school child can understand. So just I'll tell you my background. I've studied a BTech in IT from SVC Chennai and joined Sherikota in 2010. So my basic field of work in Sherikota is mainly automation. We use some PLC based systems, that is logical controllers, and we automate all the filling operations which are hazardous during the countdown activity, as well as we do high pressure leak checks of all the rocket components to qualify them for flight. So mainly I'm into automation and I'm a software person, but the concepts which I'll explain are mostly mechanical concepts. So even I am not expert in this, so I'll try to convey what I hear from other people when I work there and what I get to listen from my experience in ISRO. So just before going to rocketry, we'll just define what is space. So that's a Hungarian scientist known as Karman. He defined space as a distance of 84 kilometers from the surface of the Earth. As we all know, Earth is divided into stratosphere, troposphere, mesosphere, thermosphere, exosphere. So any distance which is above 80 kilometers, 83 kilometers from the sea level, it's known as space. So if you fly at this height, you can tell that you have touched space and come back. This is like a purely a technical point of view. This distance is called as a space and it is not belonging to any country. It is open to all. So mostly of space stations will be flying around in and around 400 kilometers from space, or aeroplane will be flying around 15 kilometers from space, and anything above that is called as outer space. And satellites will be mostly in around 600 kilometers from space. So just this is to define what is space. Next, we'll go for flight. In case of flight, there are four main factors. We should know the definitions of these three. First is weight. I think we all know what is weight. It is nothing but what is the force of gravity acting on us. Next is lift. Something which can carry you above is known as lift. And thrust. Something which is pushing you is called thrust. And something which is going to stop you, like friction, is called drag. So we'll take a simple concept of flight, whether be it a airplane or a bird. So in a normal flight, your plane is moving forward because of a thrust, and when it's moving forward because of the shape of the wing, there is a difference in pressure from the top of the wing and the bottom of the wing. So this difference in pressure due to the air is going to give you lift. When lift is more than the weight of the plane, it will fly, and the opposite to the thrust is called as a drag. So this is the basic principle of anything which is working which is going to fly in our atmosphere. When it comes to space, these rules will be different. Same concepts will not apply. I just come to space. So we'll show you how a rocket works. So mainly if you consider a rocket, it is going to fly in a space where there is no air. So whatever concepts we have seen for a plane will not be working out for a rocket. So a rocket doesn't rely on wings as there is no air, and it depends on the third law of motion, Newton's third law, where every action gives an equal and opposite reaction. So a rocket basically combines a fuel and an oxidizer to generate a hot gas. This hot gas will be pushed out of the nozzle of the rocket. So when a gas is pushed downwards, it will create a thrust upwards. When the generated thrust, that is upward push, is more than the weight of the rocket, it will lift the rocket through space. So this is a very basic principle of how rocket works. So again, from this we know that the way in which aircraft fly and the way in which a rocket flies, these two are not the same. Concepts are different, Aircraft needs air to fly, as the drag is lift is generated by the air. It needs wings to fly, and also aircraft will carry only fuel, as it is flying in a space, flying in the air. Oxygen is available in the air, so it will use the oxygen from the air. It will use the wings, and it will use the air to fly. A rocket will work slightly differently, as it cannot work as it works without air. It uses ejection of hot gases to push it up, and it carries its own oxygen along with fuel, as there is no oxygen in space.
Akshay, question.
Yes.
Can you go back? So
Okay.
what how no no this one, yeah. What is the need to oxygen? I know in terms of rocket, but from an aircraft standpoint, how does oxygen in the external air matter for the wings for lifting? Because air can still,
Because
let's
in an aircraft, your turbine is like a engine. It is going
mhm.
to burn the fuel. To burn the fuel, you'll get the air from
Oxygen.
outside.
Understood. Understood.
In
Okay, got it.
case of rocket, it's flying in vacuum. There is no
Mm,
oxygen. So you
okay,
should carry your own oxygen or oxidizer. Technically speaking, oxidizer.
understood. Okay, thank you.
Okay. So again, the same principle I'll explain with a simple concept. You take a balloon, you blow the balloon and close the mouth. It will not fly. The moment you release the mouth, it will fly. Because when you close the mouth, the air pressure of the air which you have blown will be acting equally in all the directions. The moment you open the mouth, this air will flow out here, and there will be an imbalance. Air is escaping here, and this pressure will be acting in this direction. So this will create an imbalance. So for this action, you get a reaction, the balloon flies. So this is a basic principle which we use in a rocket. Instead of the mouth, we use a nozzle. The nozzle, when we push hot air outside, it creates a thrust which will push the rocket in the forward direction. So this is the same thing in some technical form, where when you eject hot gas, it will create a forward thrust and pushes the rocket in the forward direction. So basically, till now, what we have seen is that rockets should have a fuel and an oxidizer. These two combine together in a chamber known as combustion chamber. When they combine, they generate large volume of gases. These gases, they will be pushed out of the nozzle as exhaust gases. When they are pushed out, they create a forward thrust, which is going to push the rocket above. So this is a very basic principle of how a rocket is going to push itself to space.
Yeah,
So,
Akshay, one quick question. Huh? So
okay,
if you can go to the first slide, no, where you're talking about the different layers of the atmosphere.
okay,
Uh, so when we are in the troposphere, right, you get
hmm,
oxygen. So
correct.
there should not be any issues for the.
I'll come to that. I got your
Oh,
point.
okay, all
Just
right,
you
all
be
right.
on. I'll come
Okay,
to that
okay,
one by one.
got it.
Okay. So next we'll come to one more term, one more term which is going to be used in rocketry called specific impulse. Specific impulse is like your efficiency. It is a measure of how the propellant is going to be used efficiently in a rocket. It's mainly if you burn a unit mass of a propellant, how much thrust will be gained when you burn it. So, and its unit is seconds. Technically speaking, if I tell I am getting a specific impulse of 300 seconds, it means if I burn 1 kg of propellant, it can generate 1 kg of thrust for 300 seconds. So whenever you talk about rockets or some fuels used in rocket, like mileage, they or like we'll tell a petrol is giving less mileage, diesel is giving more mileage. So like that, the term which you encounter is called specific impulse, and rockets will have different types of fuel, again which I'll cover in next slide. Typically for a solid based fuel, the specific impulse will be around 250 seconds. For liquid it will be higher, 300 to 400 seconds. Just it's a thing like specific impulse implies how much is the efficiency of the propellant burnt.
Okay, here the time means with 1 kg of whatever the fuel which is burnt, it can fly for 300 seconds continuously. Is that the
No, no,
understanding?
no, no. For 1 kg of propellant burnt, you get 1 kg of thrust for 300 seconds. So you cannot tell fly continuously. You should know that that much Newton meter of thrust is produced for how many seconds.
Okay, okay, which
Okay.
means 1 kg of thrust, which is equivalent to this 290 seconds, can result to in 10 seconds of travel
No,
also.
no. When you
Yeah.
burn 1 kg of propellant, it will generate a pushing force of 1 kg for 200 seconds or 300 seconds.
Pushing force of 1 kg for 300 seconds. The distance which is covered here or the time
Distance doesn't matter because
doesn't matter.
just it is
Okay.
going to produce this much force for this much seconds.
Okay. I'm just
Okay.
trying to draw parallels or Is this
No,
anyway,
no.
it can be very very orthogonal or random random association, but is this in any way related or uh, how do you say, the same mechanics how EV vehicle operates? Because when I give from an eco plus mode to a speed mode, right,
Hmm.
it goes like crazy, right? Usually the in a diesel or a petrol car, it does not happen. So thrust is higher. Is it in any way related or some completely different topic?
Okay, I'm not able to. I mean, I don't know what whether I'm telling, but assume I take one kind of fuel. If I want
Mm-hmm.
to compare two types of fuel,
Mm-hmm.
and if I want to know which is more efficient or which can be used, this number will come into picture.
Understood.
It is just a
Which
way
is
of
true here.
comparing.
Here, which
Yes.
is petrol versus charge,
It is just
lithium
for
charge.
comparing two types. Some
Understood.
metric should be there to compare two
Understood.
types of fuel. It's one of the metric. It
Which
is
is
not the
special.
one. It is not the only metric. It's one of the metric, but it is important. If you
Okay.
talk about rocketry, if you talk about propellants or fuel, this is the first term which you will encounter called specific impulse. Mainly for a chemical engineer who is working in rocketry, this is the first. It's like ABC for them.
Got it. Thanks.
Okay. So there are different types of propellants: solid, liquid, gaseous, ion. So I'll just cover one by one. Solid is like your Deepavali rocket. It will be cast in a casing. Moment you ignite, it will fire. It is very simple. There is no mechanism. There is a casing. There is some like a gunpowder or something. Some solid propellant is there. Moment you light it in fire, it will generate the hot gas. It will fly. It is very simple. It is reliable because you have to just pack it and keep it. If you light it, it will fire. There is no moving part. There is no mechanism for it to fail. Next comes liquid fuel. Next comes liquid fuel. 1 minute, my mouse is not working. 1 minute. Yeah. Next comes liquid fuel. You can this analogy to a liquid fuel is like your bike or some petrol engine, where there is some mechanism to control the flow rate of the liquid and the oxidizer flowing inside the engine, and it is throttleable, it is controllable, and you can restart it also. If you want, you can switch it off and use it for coasting. Like when you remove your leg from accelerator, your vehicle will coast for some time. Again, when you want, you can press it. So those kinds of control is possible, but it is complicated, and but it's powerful. Third one is cold gas propulsion. This cold gas propulsion is same as your balloons example. You compress a gas in a bottle. Whenever you want, you release the gas, it will push it forward. It is just like the balloon. Last one is ion. Just I'll tell you, if you take a solid propellant, the solid grains will be cast inside a casing, and there will be an igniter. This igniter will generate a spark. This spark will burn radially. This will generate hot gas flowing outside the nozzle, generating the thrust. So it is simple and reliable. It is having good shelf life. You can just cast it and keep it ready, and whenever you want, you can use it. It's like the same concept is used in your missiles also, missiles or everything. So this is the concept of solid, and this is the most reliable type of propellant.
Can you give
Next,
us any examples of solid fuels, Akshay?
I'll come again. My slide is covered.
Okay.
Next slide, I mean future slides, it's covered. When I explain about one, I'll try to explain about one vehicle of ISRO. In that, I'll explain each and everything in detail. But solid is like a Deepavali rocket. Your rocket, Deepavali rocket, you can keep it in your home. You can fire it next year also. It is not going to spoil, and it is easy to store and maintain, and it is having simple mechanism. Just you give fire, it will fire, light up. So you just take the analogy of a Deepavali rocket. Even if you see in the ancient times, when the Chinese, they were trying to make rocket, how they started is like, for their war, they tried to put gunpowder in a bamboo stick, and they ignited it and saw that it was flying. So that's how, by mistake, they have invented the solid propellant. Even in home also, you take your mastic head, put it inside and fire, it will go somewhere. So that is like a solid propellant. It is a very simple mechanism. Shall I go to next one? Hello.
Yeah, yeah, please go on.
Ah. Next will be liquid. So liquid, there are two types of liquid propulsion: monopropellant, bipropellant. I'll tell you what is monopropellant. There is only one propellant which will be kept in a tank. There will be a pressurizing cylinder which will push the propellant through a catalyst. When it is flowing through the catalyst, it will heat up and generate hot gas. And this hot gas will be expelled from the nozzle to generate the thrust. So this is called monopropellant. Next will be bipropellant. In bipropellant, you need a fuel and an oxidizer. So both will be pushed, and they'll be injected into the combustion chamber. and there they will combust and provide some hot gases which will be pushed outside the nozzle, and they'll be used for propulsion. Third is the cold gas. Like you have a gas bottle, you keep a pressurized gas, like our LPG cylinder or something. You keep it pressurized, or even your balloon. There will be a valve. The moment you open a valve, this gas will come out. It will push it forward. So this is like cold gas propulsion. Last will be ion propulsion. Your ions propellant will be ionized, and the positive ions will be pulled. This will generate the acceleration, and it will push forward. So these are the four types of propellants. Next, we'll come to staging. If you see any rocket, rocket will be built as stages and will not be a single piece. When a rocket flies, a portion of it which is consumed will be falling down and the rest will fly. This is known as staging, and each stage has its own engine in case of liquid, or motor in case of solid, its own propellant. When it has done the work and is imparted the required velocity, it will be dropped because it is dead weight, and carrying it further is going to waste our resources. So this is called staging. It is going to reduce the dead weight, and as the dead weight falls, the remaining weight will be reduced. So with again little propellant, we can achieve the required velocity. So why it is done? It's like if you take lower stage, it has to go through our atmosphere, so it has to generate high thrust. So lower stage will be optimized for high thrust to flow through the atmosphere. Upper stage will not have the atmospheric resistance, but it has to travel for a longer duration to reach the greater height. So it will be optimized for vacuum area with higher specific impulse. Again, details will come in next few future slides. So this is the point of staging with lower stages and upper stages.
I always used to wonder when these news channels show these launches. No, why is this some part being detached, etc. So this is the
Because
reason.
once
Okay.
its purpose is solved, there is no
Yeah,
point to carry it forward.
yeah,
We can just leave it.
yeah.
Again, this lower stage, they are mainly made up of solid because they have to lift the total vehicle and provide the initial. They have to come out of inertia. They have to provide the initial thrust. If you see solid, they can be packed densely compared to a liquid. So more mass can be burnt in a shorter time in case of solid. So more thrust can be generated and a greater lift can be generated. So if you take a solid propellant, even though its specific impulse is comparatively less than liquid, it can be packed in a higher density. So more mass can be packed in a particular unit volume, so it can be used for generating the initial thrust. So if you take ISRO's vehicle, ISRO is having three types of vehicle: PSLV, GSLV, Mark 3. Again, I'll explain everything in detail, but as we are talking about propellant, we see ISRO is having solid, two types of liquid, and cryogenic propellant. So solid propellant is always used in the first stage, and in third stage of PSLV it consists of two things: this poly hydroxyl terminator polybutadiene, which is a polymer, and aluminum as a fuel, and ammonium perchlorate as oxidizer. So these two will be combined as a paste. They'll be put in an autoclave, and they'll be solidified and kept in a motor, and it will be a solid propellant. If you go to the second stage, it will be liquid. These are like normal liquids kept in some 12 degrees and 18 degrees. That is hydrazine, unsymmetrical dimethyl hydrazine, and nitrogen tetroxide. This oxide is the oxidizer, hydrazine is a fuel. And next will be used in the fourth stage, which is monomethyl hydrazine and mixed oxides of nitrogen. And finally, if you go to a bigger vehicle, we'll go for cryogenic. Cryogenic is nothing but hydrogen is the fuel, oxygen is the oxidizer, but these two will be in a liquid state. That is, they'll be stored in minus 250 degrees. So these are types of.
Akshay, question.
Yes.
When you say first stage here, you are talking about the bottom most is the first stage, correct?
Correct. Again, stages I'll explain one by one. My next
Okay.
slides are having all the stages.
Understood.
Okay.
And is it a universal standard that across countries, four stages is the maximum or
No,
no?
no, no.
Okay. It
In
can be more.
ISRO, we are having different types of vehicle. I because I cannot cover all the vehicles of all
Okay.
centers. I am covering only whatever is done by ISRO.
Okay. But four is minimum, is it?
No, no, no.
Oh,
There are vehicles with two stages.
okay. Understood.
It's available.
Okay.
So because PSLV was the first vehicle made by ISRO, first commercial vehicle made by ISRO. It was very primitive. It is developed in the 1970s. So it is having four stages. But as we are growing further and we are maturing more, we are coming to less stages. I'll explain in the future slides. So this is the most basic vehicle of ISRO. It is the oldest vehicle of ISRO, which is commercialized. It consists of four stages. So alternating between solid, liquid, and liquid. So this bottom portion, this India, this logo you're seeing, this total thing is a solid stage. This total thing is 139 tons in weight. This white color what you're seeing is the second stage or the liquid stage, which is 41 tons. That is a propellant loaded. It's 41 tons in weight. This red color what you're seeing, that is the third stage, which is 7.6 tons in weight. That is the third stage. And the topmost thing along with satellite, you have the fourth stage, which is 2.5 tons in weight. So as you're saying, initially huge push is required. So bottom stage is very heavy. Once it's consumed, this dead mass will be falling down. Next will be lesser, 41 tons, which will impart additional velocity. But as you are escaping the Earth's gravity, your distance from the Earth is increasing, your air is becoming vacuum, your force required to impart the velocity may be less, thrust may be less. So further stages are having less weight and they are smaller. This PSLV is mainly used for sending satellites to low Earth orbit or sun synchronous orbit, which is very less, which is around 300 to 400 kilometers. And this vehicle's height is 44 meters. The second vehicle is GSLV. It is three stages. What you're seeing bottom, this area is a solid stage with four liquid strap-ons. This is the second stage. This solid stage and the second stage is same as what you see in PSLV. The third stage is the cryogenic stage where we fill liquid oxygen and liquid hydrogen. This vehicle is a heavy lift vehicle. The earlier PSLV can lift 4 ton for low Earth or 2 ton for sun synchronous orbit, but GSLV can lift 2 ton to GTO, that is geosynchronous orbit, which is at a higher elevation, and its height is 49 meters. As you see, this bottom is 139 plus 4 strap-ons to a combined to of 138 ton, and then second stage is 41 ton, and third stage is 12.8 ton. This is the recent vehicle, the
I have
latest
a
vehicle.
question
Yes,
about this, Akshay.
tell me.
So when you say stage one is 138 tons with all the four strap-ons,
Yes.
after the fuel is burnt, what would be the weight? Because this is the part that sort of falls off, right?
When I tell about the ton, I am mainly talking about fuel because the other metallic portion they are negligible. They'll not be having much weight. So whenever I mention about
Okay.
the tons, it is mainly about how much kg of fuel is filled into the vehicle
Okay,
because the
thank
other
you.
portions are negligible.
Got it. Thanks.
And the stage one, you say solid surrounded by this liquid attachments, right?
Strap-ons. Ah,
So
yes.
which means for the initial thrust, first solid is executed on that exhaustion, the other one is executed
No,
before
no,
it
no.
falls off.
Actually, if you see ISRO, initially they perfected the PSLV.
Mm.
So when they are going for GSLV, this first stage, what you are seeing in PSLV,
Which is fully
the
solid.
solid, same thing is used here. That is 1:1.
Okay.
Whatever you're seeing is 1:1. Then the second stage, that is 41 ton stage, what you're seeing in PSLV, that same stage is kept here. These four strap-ons, what you are seeing, are exactly same as the second stage. It's slightly different nozzle design. And if you take a countdown, these four L40 strap-ons will be ignited first before T0.
Wonderful.
At
Ah.
T minus 3 seconds, they will be ignited,
Mm.
and they will the fourth generator will be measured. If all four are generating equal thrust, then solid will be ignited. Because
Understood.
solid once ignited cannot be stopped. It is not controllable. But
Mm.
liquid, moment you ignite, if you it's like a bike motor only. You can stop it
Mm.
also in between. So we'll see if all strap-ons are working, if all strap-ons are generating equal thrust. Because if they're unequal, this flight will be deviating. They should be equal. So if all thrust on four strap-ons are equal, so this will be ignited 3 seconds before T0. T0 is the time when actual liftoff happens. It will be ignited 3 seconds before that. And when all four are performing normally, solid will be ignited and it will be flying. Is it okay?
Yep. Thanks.
Ah. So next, this is a recent vehicle. This is see now we have gone from 4 to 3. The last vehicle is LVM3, launch vehicle Mark 3. This is having only two stages. You see these two strap-ons, what you're seeing, they are solid boosters. Each one is 200 tons each. Like each strap-on is 200 ton. So we have 400 ton. The middle stage, what you're seeing is 110 ton, and cryo stage is 27 ton. Earlier, if you see GSL, it was 12 ton. Now this is 27 ton, and this is having a capacity of 4 ton, double the capacity of Mark 3. As you see, when you are going for more stages, the mechanisms will be more complicated. When you go for less stages, it will be simpler. So again, we are going towards reducing the number of stages. So from 4 we have gone to 3, and now we are in 2. So here if you see, these two solid motors will be ground lit, and once it's flying, this first stage will be air lit, and then cryo stage will be lit. So this is a sequence. So just for understanding about the different components of rocket, I'll explain how a typical PSLV works, because it is the first rocket of ISRO and it will cover almost all mechanisms which you may see, which is reused in other rockets of ISRO. PSLV comes in three variants. This is generic, core alone, that is without strap-ons, XL with additional strap-ons to just change the payload capacity. But whatever concepts we see will be same. So if you take first stage, so whatever picture you are seeing, that is the first stage of PSLV, which is made up of hydroxyl terminated polybutadiene (HTPB) with marrying steel. This casing is steel casing with propellant. So whatever weight I told, 139 is the weight of the propellant. And if you take any flying object in space or in air, there will be three controls: pitch, yaw, and roll. So in the picture, if you see, there is one axis like our X, Y, and Z. This one axis is called pitch, other axis is called yaw, and roll. It's like normal English roll only, roll control. So when this vehicle flies, simply you ignite it, it will generate the hot gas, it will fly. But how do you control it? So you have to control pitch and yaw. So for controlling pitch and yaw, we have some chemical called perchlorate. If you see here, na, this nozzle will be having different nozzles. There are 24 nozzles like this. So there are four quadrants. So 6 into 4, 24. 24 nozzles are there. So assume it has to fly this side. This set of six nozzles will be opened. Perchlorate will be will be pumped here. This flame will be deflected this side. So thrust will be generated in the pitch side. Either it is pitch plus, pitch minus, yaw plus, yaw minus. So using this perchlorate, we can control the pitch and yaw. For roll control, if you see, this motor is there. This motor is having a liquid engine. This liquid engine will be used for generating thrust here to control the roll. So just this is a picture of the nozzle with the strontium perchlorate controlling the pitch and yaw control. And the strontium perchlorate will be stored in this tank over here. This tank will be connected here and it will be activating all the nozzles. Then roll control is through this one, and whatever you are seeing here, this is the igniter. This igniter will be kept in the top of the first stage. So this is how a first stage works. Next we'll go to second stage. This is the second stage of a PSLV made up of aluminum alloy. So there will be two tanks here, one for the fuel, one for the oxidizer, and an engine. Again you have pitch, yaw, and roll. So for controlling this pitch and yaw, this engine will gimbal. I think everyone is aware of how a gimbal works. So this nozzle will move either y plus y minus p plus p minus side. So with this pitch and yaw control will work. And for roll control, there will be a nozzle here which will release hot air gases to control the roll. So this is the second stage. Next comes to the third stage. Third stage is almost same as first stage, but with lesser weight. And this is made up of Kevlar, some composite made up of Kevlar. Again, here this nozzle will move left, right, up, down for the pitch and yaw control. But roll control is done in the fourth stage. Like these two will be attached. If you see in the actual flight, this third and fourth will be coming as a single module, and this fourth stage roll control will be used for third stage also. Next we'll come to fourth stage. Again, fourth stage is made up of aluminum alloy with again two tanks here and a nozzle here. Here again this nozzle will be gimballed for controlling pitch and yaw, and roll control thrusters like hot gases will come out of small nozzle for roll control. Again, if you see one by one, the first stage burns for 110 seconds, very short duration, and 237 ISP. Second stage will be burning for a slightly more duration. Third stage again 100 because it is same as first stage. And the last stage will be there for 300 to 500. Again, this depends on the mission. If the orbit is less, it will go for 300. If the orbit is more, it will go for 520. So second, this is the fourth stage of a rocket. Again, when I come to liquid stages, there are two types of liquid engines: pressure fed engine and pump fed engine, which I'll explain to you in detail in the next slide. Mostly the last stage of a PSLV is pressure fed. All the other stages are pump fed. Now, if you see the schematic here, the left one is a pressure fed engine, right one is a pump fed engine. If you take a pressure fed, this is the oxidizer tank and a fuel tank, and there are valves. Like these are the control valves, electrically controlled. When you open the valve, this fuel will come to the nozzle, they will ignite and they will generate hot gases and it will generate the thrust. But logically, if you see, when liquid is coming down, this gap will increase. So this gap is like your that is in technical term is called ullage. Ullage of the thing will come down, but we are in vacuum. If you take our normal earth, when liquid comes down, this gas will displace the volume, but in space there is no gas. So there is a gas bottle, high pressure gas bottle. So this gas bottle will be used for giving the pressure. So whenever liquid is consumed, this has to go at a particular flow rate. To control the flow rate with which it has to enter the nozzle, this gas will be used for pressurizing this one. So this gas will flow through a regulator. This regulator will just send the required gas pressure to these two tanks. They will push the fuel and oxidizer to the chamber where combustion will happen. So mainly this pressure fed system will be used for upper stage, because in upper stage your payload weight should be very less. And whenever you go for a pump fed system, you cannot afford to add a pump here, because again pump requires some components which will add more weight to the vehicle. So this is used for some simple systems like a upper stage of a vehicle. The second one is a pump fed system. In pump fed system, I'll just tell one more thing. In a pressure fed system, the volume of the the volume of the tank will be very less. So this pressure is sufficient to generate the required pressure to replace the volume of the fuel consumed. In second stage, this volume will be very high. So if you go for a pressure based system, you need to have very large gas bottle to displace the huge volume which will be consumed when it's flying. So instead of pressure fed, use a pump fed system. A pump will be there. In the pump, gas will be generated. That will run a turbine. Turbine will just suck the propellant and the fuel, the oxidizer and the fuel from the tank, and it will spray it to the test chamber. And when they are sprayed at a particular flow rate, they will generate the required thrust. So this is a typical diagram between a pressure fed system and a pump fed system, mostly used for any liquid stages. So the second stage of a PSLV is a called as a Vikas engine. This Vikas engine is fully in-house engine, and it is a replica of the European Space Agency's Viking engine. And if you see here, this is the fuel pump, the oxidizer pump. They will be sucked from the tank, and they will be injected here to generate the hot gases. So it is the rate 175 kg per second is required for oxidizer, and 103 kg per second is required for the fuel to generate the velocity of 2.3 km per second. Because when it's flowing at this rate only, it can combine at this pressure, this combustion chamber, to generate the required thrust. So I'll just explain a simple schematic of how this pressure fed pump fed system works. U is the um, propellant, N is the oxidizer. So these two tanks will have the fuel and oxidizer, and these two propellants are called hypergolic. When you tell hypergolic, these two propellant, when they combine, they will generate the hot gas. They don't require any ignition source like a spark plug or fire. The moment they come in contact with each other, they will ignite and they will generate the gas. Initially, these two valves will open. They will allow the propellant and oxidizer to come here, and they'll combine. They'll generate the hot gas. This hot gas, some hot gas, will go to here and come to an area called as a gas generator. GG is called as a gas generator. So this will give the hot gas, and this gas generator will go to this area, and this blue color is called the water tank. We will again have water. This water will come here, and because of the hot gases from gas generator, it will become steam. The steam will rotate a turbine. The turbine will rotate, and it will rotate the turbo pump. The turbo pump again will further suck both fuel and oxidizer, and it will using high pressure, it will force these two to come at the required flow rate to the thrust chamber. So this is the total system. And if you see these top four, these are the gas bottles. So these gas bottles pressure will be used for pressurizing the tanks from here, and this gas generator will be used to run the turbine pump here from the water here. So gas will be pushing from the top, the pump will be sucking from the bottom, and it will pump the fuel at required rate to the nozzle to generate the thrust. To operate all the valves, this module, command supply module, is there. This module is used to operate all the valves here. And whatever you're seeing, right, is a simple design of a regulator. I'll just explain what is this regulator. Assume I should pump everything at a fixed flow rate. So this pressure coming out of this pipe should be constant. So this is a typical regulator which is going to uh, send the fuel at 50 bar pressure. Assume if I have a very high pressure inside, I want to regulate 70 bar to 50 bar. This regulator will work in a simple concept. Assume pressure is very high here. It is going to push the blue color piston this side because one sorry, was just a minute. First, I'll give a reference pressure here. This green color is a reference pressure. Assume I want to maintain at this pressure. If incoming pressure is very high, it will push the blue piston inside, so it will cut off my incoming flow. So my outgoing flow is going to be 50 bar. Assume my incoming pressure is very less, then this piston will move this side, so my inflow will be more, my outflow will increase. So this way this regulator will work without any electrical component, purely on mechanical basis. So using regulators like this, we control the flow of all the fluids running the system, and we generate the constant pressure from here. So this is a typical working of a pump fed liquid engine. Second, next we'll go to a PS4 stage, which is a pressure fed system. Again, this is a fuel and oxidizer, and this is a small engine like this. Two engines will be kept in the fourth stage, generating 7.35 kilonewton. So here, if you see, gas bottles are there, and we have some pyro valve. Pyro valve is nothing but valve which can be opened once, like by giving electrical current, this valve will open. It's like one shot, it will open. So moment we are ready to ignite, these two valves will open. So this gas pressure will go to the corresponding tank. So the corresponding tanks will be pressurized. Once it is pressurized, the fuel and oxidizer will go to the nozzle, and they will combine here and run the engine. So this is a typical working of a pressure fed propellant tank, propellant system. So now we have seen about rockets. Next we'll come to
Akshay,
spaceport.
I have a question
Yes,
about this design that you showed.
yes,
I know you mentioned that you ISRO follows their own sort of standards. Is it the
yes.
same also for designing all of this, or are there like Indian standards for space vehicles that ISRO adheres to?
Actually, we are following MIL standards. If you see US, they have something known as a MIL standard, military standards. That is having different code numbers, MIL 1153, like that. Different codes are available. We are going to these MIL standards because when you buy a component, if we are
Mm-hmm.
making our own standards, asking the manufacturers to meet our standard may be difficult. So, like our SI units, you see, there is something called as a kg or meter, which is already part of a SI unit system. So any vendor or manufacturer will be adhering to the system. So similarly, this MIL standards is used in all aviation industry, like aircraft industry or any industry which requires highly reliable components. So as
Okay.
the aviation industry is following these standards, we are also following the same MIL standards. So when we buy a
Mm-hmm.
component, or when we are asked to manufacture some component by some third party vendors or private party, they can just easily get the standard and manufacture it. So all these things will follow MIL standard.
Okay, got it.
Under the MIL heading, some different codes are available. Each code corresponds to different components.
Got it. Okay.
Okay, okay. So now
Sim-
Thanks.
we,
similarly, of the mill thing, does Russia has its own standard, or it's a universal thing that all adopts the US mill standard?
we are adopting US. We don't know about Russia, what they are
Okay,
doing actually.
okay,
It depends on them. Actually, it is just like a way to communicate our requirements to the industry. When I tell mill standard, that will have a guidebook with
mm,
how much thickness the steel is supposed to be, a what thickness, what alloy can be used. Like some set of guidelines will be there. So
got it.
they should adhere to the guidelines. That's So next we'll come. Now we have seen a rocket. So to launch a rocket, we need a port. So ISRO spaceport is in Sriharikota. If you see here, Chennai is here. If you go 80 kilometers towards the north, you will come to a town called Sulurpeta. From here, if you take another 20 kilometers, you will come to Sriharikota. This total island is called Sriharikota. So Sriharikota is having various facilities to take care of all the launches. So first we require the solid boosters. Solid boosters are high capacity, like 100 tons, 200 tons. So they cannot be safely transported from one place to another. So in Sriharikota itself, we are having a solid motor preparation complex where we prepare all the solid propellant. As it is not going outside of our boundary to public place, the top portion of the island, if you see, this total area will be used for solid motor production, and they will be transported locally. Next, we have ground and high altitude test facilities. Like whatever components we are making, they have to be tested. So for that, some test harness is required, and a safe place is required to burn them or test them. So these test facilities are available. Next, we have vehicle assembly and integration facilities. If you see any launch, you will see something like the umbilical, this tower or this building. This tower is called as a umbilical tower. Umbilical tower is nothing but it contains various electrical and liquid pipes running over the entire height and going to the different areas of the rocket. And one more thing, what you're seeing here is the assembly building where rocket will be stacked on top of each other. They'll be lifted and packed. So these kind of assembly buildings and integration facilities are available. Next, we have the actual launch pad where you keep the rocket and you have a mechanism of monitoring the rocket health and igniting the launch rocket. Next, you have the control center. Whatever seeing you're seeing right now, this is the mission control center. This is only shown to you when there's a launch in live telecast actually, where all the mission executives like chairmen and directors will be sitting there and they'll be monitoring various vehicle and satellite parameters. And once the vehicle is lifting off, you have all the radar and tracking systems where the radar will monitor the trajectory of the rocket and see if it's going the intended path or not. And in case if it's deviating from the intended path, the rocket will be destroyed using a destruct command. So all the tracking facilities are available. Then satellite receipt facilities, like ISRO not only launches our own satellites, but we also launch satellites from various customers. Again, for receiving the satellite will have a standard interface and a standard handling mechanism. So all the handling facilities, which is almost same as whatever you see in other countries, is available in Sriharikota. Next will be propellant storage facilities. Like all the rocket requires thousands, like hundreds of tons of fuel, and all the fuel should be stored, manufactured and stored in a secure area, because these fuel they are highly carcinogenic and they are highly explosive. If you don't handle them properly, they may explode and even damage the area. So they are stored remotely and a proper monitoring mechanism and storage mechanism is kept. So all these things are combined and it all the facilities are available in Sriharikota. So if you see, right from the vehicle production to the integration, even fuel filling and launch, total end-to-end work is happening in Sriharikota to support all the vehicles of ISRO and also to support all the future vehicles of ISRO, and is the nerve center of all our launching program. So that's it. I'll conclude my presentation.
Akshay, I had a question
Uh,
on the last few slides, again related to standards, but this
okay.
time coming from a perspective of standards for the building itself. And I did try to Google as you were talking as to who designed the space center.
Okay.
Um, is Are the building standards also international? Are there any standards? Because you spoke of storing, fuel that's highly
If
carcinogenic.
you take about fuel, we follow PESO standards. PESO.
What is that? This is the first time I'm hearing.
Just a minute. I even actually we are using in our meeting, so I am also using that acronym. Just I'll tell you.
No, I'll Google it. It's called
Just
peso. Is
because
it
suddenly I'm also
PESO?
not remember PESO. You just see PESO.
Okay. Okay. Will do. Thanks,
Uh,
Akshay. Thank
uh.
you.
Actually, can you
So,
go back
every
because
year,
you're
PESO is actually Petroleum and Explosive Safety Organization, PESO. It is a standard under Government of India. So if you see in
Uh-huh.
Sriharikota, there is one separate division called as range safety. So this range
Mm-hmm.
safety division, their job is to ensure that standards are followed everywhere. All safety standards are followed. So all
Mm-hmm.
OSHA standards and PESO standards, they are the
Mm-hmm.
people who will ensure that it's implemented. And from PESO, every 3 or 4 months, some external team will come for auditing all our tanks. Because as I work in the
Mm-hmm.
liquid storage facility, I'm in the automation portion of those facilities. So you have seen,
Mm-hmm.
and each storage area we keep some pollution sensors. So in 24/7, these pollution sensors are monitoring the pollution levels in the area, and even SMS alerts and monitoring is sent in case of any leak or something. And even if there's a leak, we have a contingency procedure, and we have the
Mm-hmm.
neutralizing chemicals readily available. And
Mm-hmm.
and we have our own fire tendering team and safety response team, which is operating in 24 hours, 24/7 basis in Sriharikota itself. We have our own safety team and our firefighting team. If you see, Shar
Mm-hmm.
is having its own dedicated fire station with some fire engines and safety team.
And an
And
associated question.
regarding
Ah.
building, we have our own design team. Uh,
Mm-hmm.
where they design this all each and every structure which is going to be used in Sriharikota will be designed by the design team. They will ensure that the buildings are meeting the required specifications. Like if you take our assembly building, they should withstand cyclone winds and they should withstand explosion. And if you see each
Mm-hmm.
building, they will not be near each other. If you see one building is here, other building is there. There is a safety radius So
Yeah,
all the
that.
design considerations will be taken care
Hmm.
when we design each and every facility. Even the lightning tower, this grounding mechanism, routing, everything is designed in-house by our own engineering design team actually.
Nice. So, is there also like a way to, I mean, a way that the whole how do I say, the security net? I mean, aerial
Uh,
security, because
Yes,
like
we have
military bases.
this
Huh,
CASF. Have you seen in airport? CASF will be there. Same that
huh.
CASF team is deployed in not only Sherikota, in all government establishments. Even if you take DRDO, BARC, ECIL, Election Commission of India, if you take any government establishment, they are
Mm-hmm.
secured by CASF, Central Industrial Security Force. So they are actually paramilitary armed police force, and they will be patrolling the area continuously. And if you see our sea coast is having actually this electrocuted security fence. And right
Mm-hmm.
now, last year we are even proposing radar-based monitoring of our sea coast, and we have our own QRT team, which will have armored vehicles for protecting the total area. And even entry to Sherikota is prohibited. Without proper clearance, people cannot enter the island actually.
Very interesting. Thank you, Akshay.
Even in Sherikota also, we have multiple levels of security. Our admin building will be behind one gate, that is called
Mm-hmm.
gate one, and our technical buildings will be behind a second gate. So gate one will have one level of security. Gate two will have bunkers and armed security guards, one more level. And if you go to launch pad, again near launch pad there is a security barrack with one more facility. And again, if you enter the launch pad area also, if you want to climb this tower or enter the
Mm-hmm.
vehicle, there will be one more level of security. And for all these people, we have three paramilitary barracks in house in our Sherikota itself.
Nice. So we're actually speaking to a VVVIP. Thank you so much, Akshay.
Okay, okay,
Yeah, actually, a couple of
Aksh-
questions on this. Sorry,
okay.
yes, please go ahead.
go
Somebody
on,
else said.
Madanish.
No, no, go on. I have asked me so many questions. Your first question.
Shweta, okay.
Okay, thanks.
Uh,
Two actually, Akshay. I have two questions. One
yes.
This
is,
is Shalini, yeah. This is
Shalini,
Shalini.
yeah,
okay,
yeah,
okay.
Shalini here.
Sorry,
Yeah.
my presentation is front. I couldn't see the people.
No
Okay.
problem, no
Uh,
problem. Very
uh,
interesting. I just had two questions. One is, we saw these different launch vehicles, right? So,
yes.
are all of them, do they fall in the category of only are they like single use launch vehicles, or are
Correct,
they
correct.
like,
Correct. The
okay,
actual technical term is expendable launch vehicle. Right, they are single use only, but
okay,
we have a roadmap of making a reusable launch vehicle. So in that
okay,
regard, just if you Google ISRO's RLV, we are
okay,
having some technology demonstrators where we are
okay,
able to have a reusable vehicle that
okay.
requires multiple things. Like when a vehicle re-enters,
Uh-huh.
it has to come into the atmosphere. So there will
Correct.
be heat generation. So some
Uh-huh.
ceramic material is required to be heat resistant so that it will
Okay.
not burn up when it's re-entering.
Uh-huh.
And
Uh-huh.
it has to maneuver and come to a specific point. So
Okay.
in 2016 we have made the ceramic tiles
Mm-hmm.
which
Mm-hmm.
are capable of withstanding the heat, and
Mm-hmm.
it is able to re-enter. And last 2 years back we have made a re-entry vehicle. A prototype is tested near Bangalore in Air
Okay.
Force airstrip, which is
Mm-hmm.
able to maneuver and land in the landing strip. So it is working on it, but as our budget is limited and we have
Mm-hmm.
multiple projects happening
Mm-hmm.
parallelly, so
Mm-hmm.
this is taking some time. But already reusable launch vehicle technology testing is going on in ISRO.
Okay. Okay.
If you
Nice. And
Google RLV ISRO, you will get the relevant info.
RLV. Okay. Sure.
Reusable
Sure.
launch vehicle. Okay.
Okay. My second question is, let's say, like an industrial visit, like, if people want to visit, is there a possibility? Is it permitted? And,
It is open to any Indian citizen,
okay.
and there are two types. Either colleges may be interested to come as a industrial visit, college tour, and
Uh-huh.
people may be interested as a personal visit.
Correct. How
So
does the later work?
for college industrial visit, there is a link called PPO, PPO, some public outreach, something that
Mm-hmm.
PPO at
Mm-hmm.
shar.gov.in.
Mm-hmm.
I'll just open that link beyond.
And also for personal visits.
Personal
And when you say college, is it also
schools also.
accommodated for schools? Okay, thanks.
Yes, schools, but I think only for 10th and above, not for
10th and
kids,
understood.
Okay.
not for primary. One minute.
Okay.
I'll just open the link. Just go to this website.
நம்ம மதுரேஷ் இந்த மாதிரி இடத்துக்கு நம்மள கூட்டு போயிருந்தா இஸ்ரோ ஜாயின் பண்ணிருக்கோம்ல.
இவன் என்னமோ that's a topic for another day. What made him apply and then get
And
into
there
ISRO.
is one more thing. We have a launch view gallery. So when there
Uh-huh.
is a launch, on the day of launch, you can come and visit the launch view gallery also. So this
Okay.
is our website, shar.jv.in. Shar is
Okay.
Sriharikota. If you see
Okay.
here in point number 1 for facility or industrial visits, you drop a mail to ppo@shar.jv.in.
Okay. Okay.
So
Interesting.
from the college or school letterhead, I think around 140 students or two buses,
Mhm.
maybe allowed per school or per college on a particular
Okay.
slot.
What about personal visits? Like,
Personal visits means actually we have a guided tour on Monday
okay.
and Friday. Every
Okay.
week,
Okay.
Monday and Friday, and
Okay.
some appointment has to be booked. Like you have to contact me, I have to arrange that.
Okay. Okay. Interesting.
Okay,
Thanks,
and
Akshay.
just you have to inform some 3 or 4 days before you come because I have to
Okay.
get some signature and clearance for that.
Okay. Okay. Great. Thank you. But very
Understood.
interesting session. Thanks.
Okay.
So, Akshay, one
Again, for
quick
second
question.
point is like anyone is interested in internship also. This is the link for
Okay.
college
Uh,
students who are interested in internship.
So one quick question. With regard to
Yes.
Sriharikota specifically, the rocket launch is like done mostly on the equator side, right? Near the water bodies. Why is it specifically done in that position, like on that location? Or is there any advancement where we can do it from anywhere across the country?
Sherikota is chosen because again equator is one point, but
Mhm.
mainly we have a large area which is uninhabited. You see other side it is Bay of Bengal
Mhm.
and if you, I'll just open the map. If you see Sherikota, here you have Pulicat Lake, here you have Bay
Correct.
of Bengal. So if anything happens, this loss of life will be minimized.
Okay.
So that is one point. And mostly launch vehicles, actually when you are launching from the equator, the Earth rotation will
Mm.
give more inertia when it is going to impart more inertia when it's going to fly in the direction actually. So that's why
Okay.
people prefer to launch from the equator.
So that reduces the fuel cost and the payload and
It'll be
capacity and all, right?
it'll just be slightly more efficient than launching near the poles.
Okay. Makes
That
sense.
push given will be more. And there is one more thing is like from Sherikota, when we are launching from Sherikota for mainly a PSLV vehicle, that is polar vehicle. Actually, there are two types of orbit. One is polar orbit and geosynchronous orbit. Polar orbit will go from pole to pole, north to south. So satellite will be going from pole to pole. Geo orbit will be like this, side to side, near the
Mhm.
equator. So when we are going for a polar orbit, when we are launching from Sriharikota, there is Sri Lanka in between. To avoid Sri Lanka, we are just making a small maneuver to avoid the Sri Lanka and take a detour, and then going back.
Mm-mm.
So now ISRO is proposing one more launch pad near Kulasekapatnam, that is near
Mm.
Tiruchirappalli. So when
Mm.
we are launching from there, we can avoid Sri Lanka and go directly to the pole. So that launch pad work has started. Maybe next year it will be complete.
Okay.
So one more launch pad will come up next year near Kulasekapatnam.
Mhm. And the other part, like when we are talking about this debris or whatever it's falling apart,
Mm,
it's mostly on the water bodies, right?
correct.
So is it like somewhere when we are talking about reusable rockets, all these debris and other parts which are falling, it's like, can we avoid that, or is there any research on that part?
Yes, actually, we have our own thing called Netra. I'll show again. It's not showing Google. That is our in-house thing only. For space debris management, we have formed a team, international team, and in Sherikot also there is a multi-object tracking radar. Apart from when it is not used for launch, this radar is going to track all the debris in space. So mainly
Mhm.
we want to not only India but all the countries they want to minimize the debris in space. So all are now moving towards a reusable launch vehicle. Because it is one thing is like now we are adding earlier launches were very infrequent, so people didn't care. But now if you see
Mm.
more and more launches are coming up and more and more debris are added, it is now creating more congestion. So whenever we launch a vehicle, we should ensure that it is not going to touch or any debris will not touch the vehicle, because at that velocity if something touches the vehicle it will puncture it and will damage it also. So in that view all are planning to go for a reusable kind of technology, and we are also planning on how to reduce the debris. So one of the ways, like if you take our Other stages, if you take again a PSLV vehicle, the first and second stage will fall off into the Bay of Bengal. It will not be in space. But if you take our fourth stage, it will be roaming. It will be orbiting the space along with the satellite. It is a debris. But now we have added some mechanism where it will be deorbited. That is, retro rockets will be fired, so it will come down to a lower level of the atmosphere, so that after some time, due to gravity, it will fall back and it will burn in space itself. So these kind of debris management mechanisms are planned.
Wonderful.
So this is called passivation and management of stage. And again, now a few startups have come who are specializing this debris management. Even a few months back, I just met a person who was in ISRO only. He was an ISRO employee. He has resigned. He has formed a startup, and his startup's USP is space debris management.
Oh, business, huh? Very good.
He has started this year. He has started this year actually. I'll tell
Okay.
the name of the company. So be online. Just be online. I'll tell you. You can just Google the name. I'll share his name. You can look at the company. You look at the person's name is Chiranjeevi Panindra, Phanindra.
Oh, nice.
Cosmos of Space. His startup is actually towards this one, reducing space debris. And he got some funding also. He got 3 million funding also, pre-seed funding.
Nice, nice, nice. All right.
Yeah,
So
can you go to
over
the
to
next
you,
slide?
Mahadish. So
Yeah.
India
No,
Pakistan match வர இருக்கு.
I don't follow cricket. Oh, ரெண்டு question before we close. Next one, next போடா ஒரு நிமிஷம். The next slide, Akshay.
So okay.
Can you move slides?
Slides. Okay.
So here, what is the rationale behind this testing of ground and high altitude? Why was that required? High altitude test na, the launch pad itself will be in high altitude for some reason.
No. See, now you have a vehicle. I told you na, the main design of vehicle is a nozzle. Okay?
Nozzle top. Okay.
Nozzle la bottom. The gas வெளிய வருதுல.
அதான் nozzle, sir. Oh, sorry.
Nose cone in the top. Nose cone top.
Okay.
Bottom வந்து nozzle. இப்போ nozzle டிசைன் பண்றப்போ அதுல இப்போ nozzleோட length நீ மாத்தணும், dia மாத்தணும், something you have to do. அப்படினா you have to test it. But test பண்ணதுக்கு you cannot have a total vehicle because each vehicle is around 200 crores minimum. So on the design என்ன பண்ணுவாங்கன்னா 1:16 or 1:100 scale down model will be made and it will be tested. There will be two types of testing: cold gas testing, hot gas testing. Cold gas testing na, some normal gas will be flown through the nozzle and that pattern, the wind tunnel pattern la solluvaangala, and some pattern will be observed. So how that gas behaves, normal gas behaves when it's existing from the nozzle. Similarly, hot gas testing na, some fuel locally, some tank will be there, that fuel will be burnt and that hot gas will be passed through the nozzle. So again, what is the vibration, heat, thrust, all those things will be tested.
Oh, it's not like high altitude is outside field. Wait.
That is the purpose of testing. Okay. Similarly, if you take this launch pad, கீழ பாக்குறல இந்த vehicle நிக்குது பாத்தியா, that area is called as a launch pedestal. Okay, அந்த launch pedestal ல இந்த நிக்குது பாத்தியா, அந்த இடத்துல ஒரு hole இருக்கும். When it is flying, this gas has to be pushed and it will flow through something known as a jet deflector, JDD, jet deflector duct. Okay, the duct will ensure that this force is moving away from the launch pad and it's not damaging any of the launch pad structure or any nearby building. So this gas has to be diverted. So in the structure has to be tested. So if I want to build a new facility or a new kind of design, everything will be tested in a miniature design. Even if I want to make a small change also, one miniature version of that building or the rocket or the nozzle will be created. That will be tested with this hot gas, cold gas. That testing setup will have various instruments which will log data at 1 millisecond, 10 millisecond to see vibration, temperature, pressure, and with that structural analysis will be done and only scale down design will be made, then actual design will be made. So that is known as ground level testing. High altitude testing na, you have to test something in vacuum. So we have a vacuum chamber or பெரிய டப்பா இருக்கும். There air will be sucked out so that there is no pressure. So in vacuum, how an item behaves, I check for, we have a vacuum test facility that is called high altitude test facility, that is testing something in vacuum.
Understood.
Apart from that, we have a vibration test facility. Then some different test shake பண்ணுவாங்க, vibrate பண்ணுவாங்க, like அந்த harness நிக்குதா,
Yeah,
like
usually that ETDC types.
G
Okay.
force அவருக்கு அதை பார்ப்பாங்க. அந்த மாதிரி different test
Yeah,
facility இருக்கும்.
understood.
So
Understood.
each component, even not only ISRO, if somebody wants to test it, they can
Correct,
bring
correct.
it to ISRO and test all those components.
Yeah. I have been to ETDC in Chennai like நம்ம தரமணியில இருக்கு இல்லையா? So I've been. Okay. Second
பட் இங்க
question
எல்லாமே
is.
அங்கெல்லாம் சின்ன சின்னதா இருக்கும், இங்கெல்லாம் வந்து
Okay,
டன்ஸ் கணக்குல பெருசு பெருசா இருக்கும்.
Understood. Understood. Second question is, you talked about solid propellant production inside Sriharikota. What
Yes.
about you procure liquid and other things from market? Who supplies you? Like
Again, liquid is done by HAL. ISRO has given the order to HAL.
Okay.
They will manufacture it. They will supply it to ISRO Propulsion Complex in Mahendragiri. Mahendragiri is near Nagarkoil. So Nagarkoil will place an order on HAL. HAL and Godrej is having a consortium. They will manufacture and give it to IPRC, that is in Mahendragiri. They will first test everything is okay. They will transport it to Sriharikota. Again in Sriharikota, it will be tested and then assembled.
Understood. And beyond Sriharikota and this upcoming Kulasekara, do we have any other in India? The launch.
There are only 2 launch pads. I mean, ISRO is having only our launch pad in Sriharikota. This Kulasekara, it is still yet to be set up.
Okay. Nowhere else in India, huh?
Nowhere else in India.
Oh, okay. Okay.
And in Sriharikota itself, we have 2 launch pads, first and second launch pad. First launch pad is used only for flying PSLV. Second launch pad is used for flying PSLV, GSLV, and Mark 3. And last year, government has approved building of one more launch pad called third launch pad. This third launch pad is planned to be used for new type of vehicle. We are planning one more vehicle called next generation launch vehicle, NGLV, where we are planning to go for new types of propellants like semi-cryo, then reusable launch vehicle, this human in space mission. So that third launch pad, some 4,000 crores budget is allocated, and mostly the construction will start next year.
I think
Sriharikota, third launch pad Sriharikota. In the Kulesirapatnam, it's mainly planned for generating small satellites. And futurely, if private people wants to come and launch something, and some launch pad is required for them, so it is planned for private people. Right now, if you see in India, 2 people have launched their rockets from Sriharikota. One will be Agnikul Cosmos, that is IIT Meta startup, and one more is Skyroot from Hyderabad.
Okay, these are private companies as
These are private party. Both have done one launch from Sriharikota. They have launched a scaled down model of their launch vehicle. The Agnikul, they are doing 3D printing of cryogenic engine and launching. The Skyroot is planning a full solid rocket motor. They are manufacturing in indoor somewhere and then bringing here and launching from Sriharikota.
That's for private purposes.
The Skyroot person is actually one former ISRO employee, resigned, and he has kept a startup. Headquarters in Hyderabad.
Understood. Okay. Final question. Is the reason that all continuous investment is within Tamil Nadu, like because of Girish point on this equator thing, or is it
again ISRO's launch pad is in Sriharikota, which is in Andhra Pradesh, not in Tamil Nadu?
Correct.
Kulesirapatnam was kept in.
What is stopping us to explore Ahmedabad or say Assam?
ISRO is there in all states.
Okay.
What happened is like initially ISRO went to Kerala, Trivandrum, for இந்த சைக்கிள் புல்லட் கார்ட்ல சைக்கிள்ல போற போட்டோ எல்லாம் பார்த்திருப்பீங்கல்ல, அதெல்லாம் வந்து ட்ரிவாண்ட்ரம்ல ஸ்டார்ட் பண்ணாங்க because it was close to equator. அதுக்கப்புறம் when we are going for bigger rockets, they need a bigger area of land with less people. They have gone to Sriharikota. So rocket led things, because of the geographic reason, it is in Sriharikota. But if you go to other things, if you go to satellite this body structure, bus panels assembly is happening in Bangalore. Then satellite payload means these transponders, those things are happening in Ahmedabad. Then satellite data processing is happening in Hyderabad. Then satellite tracking is happening in Hassan and Bhopal. Then the satellite application related data processing is happening in Chandigarh. Then whatever if you take our vehicle, we have our own processor, our own microcontroller. So this processor manufacturing is happening in Chandigarh. Then for high altitude study, we have an observatory in northeast Shillong and Rajasthan. That in India, in different places, it is spread around. But in news, you are hearing more about Sriharikota because we are launching from here.
Correct. Understood. Okay.
Go to our ISRO website. You will know what are the places we are having. I'll show that map also.
You will get transferred to all these places, or because of your role, you will remain in
Mostly
Sri.
until you ask, you will not get transferred.
Okay, okay,
Somewhere actually it will be there. ISRO
that's
in
fine.
our internet it's available.
Okay, okay, all right, super. I think we are eight
Just you can
minutes
go to this.
past. Yeah,
This will show all our portals. Most
super.
it's for tracking. Most
Okay.
wait. ISRO said, get like ISRO centers and units. You can
Hmm.
just see different units are there.
Understood. Wonderful. Thank you so much. Can I request the audience or guests here to be on video so that we can take a screenshot? It's a usual procedure we do, uh, if possible. If yeah, thank you.
1 minute, 1 minute. I'll
Yeah,
also come.
you can stop sharing your screen. Yeah, that's it. Where is that mode? Adit, can you come on video?
Adit always
Yeah,
hiding
I'm
boldly.
on. Yeah.
Adit எப்பவுமே hiding boldly இருப்பான்.
தெரியலையே வீடியோல இருக்கேன்.
Aditya, hi.
Akshay earlier no.
நான் வந்துட்டேன்டா.
Really, I'm not able to see. Oh, you have
நான்
joined the
மொபைல்ல
mobile.
நான்
Okay,
மொபைல்ல பார்த்துட்டு இருக்கேன். ப்ரிவ்யூ பார்த்துட்டே
understood.
இருக்கேன் நான்.
Understood. Nitya Abhinaya possible or no? It's last call or else before I take it. I think Nitya is requiring special kudos 6:30 a.m. for her or 7 a.m. for her. Thank you so much for joining early in the morning. Let me do the screenshot. Give me 1 minute. I'm stopping the recording. 8:35. Super.